Have you ever really stopped to think about what happens when you type something on your keyboard and a result just pops up on the screen? It can feel a little bit like magic, right? Well, today, we're going to pull back that curtain. We're going to trace the exact journey data takes inside a simple C program, all the way from your fingertips to the final display. Think about a simple calculator. You punch in 2, then plus, then 2, and you just trust that a 4 is going to appear. You don't see the gears turning inside. Well, programming is a lot like that. There's this hidden journey that your input takes going through the program's brain and then coming back out to your screen. So let's follow that path step by step. So first things first, before a program can do any heavy lifting, or any lifting at all, really, it needs to grab its tools. And in the world of C programming, these tools are neatly packed into something called header files. This is the very first stage, the setup. So what exactly is a header file? Well, you can think of it like an instruction manual. If you want your program to know how to print text to the screen or how to do a math calculation, it needs to read the right manual first. And we tell it which manual to grab using that #include command you see at the top of C files. It's basically us saying, hey, before you do anything else, you're gonna need this toolkit. Now, these toolkits come in two main flavors. You've got your system headers, which are like the standard factory-issued parts that come with every C compiler. And then you have user headers, which are custom manuals that a programmer can write for their own specific project. The only real difference you'll see is how you include them. Those angle brackets tell the computer to look in the standard system folder, while the double quotes say, hey, look in the current project folder for this one. And here are some of the greatest hits. Standard.h is the big one. It stands for standard input and output, and it gives us the basic tools to listen to the user and talk back. If you need to do some serious number crunching, you'll grab math.h. Working with text, that's what string.h is for. It's all about picking the right tools for the job you're trying to do. Okay, so our program has its toolbox ready to go. Now, how does it actually get information from us, the user? This kicks off the first real stage of our data's journey, capturing the input. Let's see how a program actually listens. You know, the simplest way to listen is to just grab one single keystroke, and C gives us a few ways to do this. Getch is kind of the silent type. It grabs the character you typed but doesn't show it. Then there's Getchy, which does the same thing, but it immediately echoes what you typed back to the screen. And finally, Getcar is the patient one. It waits for you to type whatever you want and only pays attention after you hit the Enter key. There's subtle differences, but they can totally change how a program feels to use. But let's be honest, most of the time, we need more than just one letter, right? We might need a full name or a number or a price. For jobs like that, we need a much more versatile tool. We need scanf, which is C's go-to function for reading all kinds of formatted input. The real magic behind scanf is these little codes called format specifiers, things like %d for an integer or %f for a number with a decimal. They're like little instructions that tell the program exactly what kind of data it should be listening for. This is super important because it helps prevent mistakes, like trying to stuff the word hello into a variable that's only designed to hold a number. All right, the data is officially in the building. It's been captured from the keyboard and it's safely stored inside our program. Now comes the fun part, actually doing something with it. This is the process stage, and it's where we use the brains of the C language, operators. The operators you're probably most familiar with are the arithmetic ones. Seriously, if you've ever used a calculator, you pretty much know all of these already. They're the basic building blocks for doing math inside your program. So you've got your usual suspects, plus, minus, multiply, and divide. But that last one, the %sign, might be new. That's the modulus operator. And it's pretty cool. It doesn't give you the answer of a division. It gives you the remainder. So 5 divided by 2 is 2 with 1 left over. That means 5% 2 gives you 1. It turns out to be incredibly useful for all sorts of programming tricks. But programs do way more than just crunch numbers. They make decisions. And to make any decision, you first have to ask a question. That's exactly what relational operators do. They compare two things and give back a simple answer. Is this statement true or is it false? This chart breaks it down perfectly. If A is 5 and B is 10, is A less than B? Yep, that's true. Is A greater than B? Nope, false. And check this out. Notice the double equal sign for is this equal to. A single equal sign assigns a value, but a double equal sign asks a question. That's a huge distinction and a classic rookie mistake. The outcome is always just true or false, and that's the foundation for all logic. Okay, but sometimes a single question isn't enough. You might need to check if 2 or 3 conditions are all true at the same time. To do that, we use logical operators to chain our true or false questions together into a more complex one. The two big ones are and, which is 2 ampersands, and or, which is 2 vertical bars. And the rule is actually pretty simple. For and to be true, both sides have to be true. It's strict, but for or to be true, you just need one of the conditions to be true. It's a lot more flexible. This little table shows that logic in action. So we've gotten the data, we've processed it, we've made some decisions. What's left? Well, we have to report back to the user. It's time to look at the final piece of our journey, the output stage. If scanf is the program's ears, then printf is definitely its voice. It's the main way a C program communicates back to us, showing text, numbers, and the results of its work right there on the screen for us to see. Hey, does that look familiar? Printf uses the exact same format specifiers as scanf to know what kind of data it's supposed to show. But it also has these other little tools called escape sequences. The most common one is /n, which just tells the program to jump to a new line, like hitting enter, and /t makes a tab. These are what let you make your output look nice and organized instead of a jumbled mess. Okay, before we wrap this up, there is one last really crucial rule about that process stage we need to talk about. If you have a bunch of operators all in one line of code, how does the computer know which one to do first? Well, it follows a very strict order of operations, just like we learned in math class. Yeah, you probably remember PEMDAS, or maybe BODMS from school, right? Parentheses, exponents, and so on. Well, C has its own version of that, and it's called operator precedence. It's basically a built-in ranking system that tells the computer exactly which calculations to perform first. Let's just walk through this example right here. We've got 9 plus 3 times 2 minus 1. Without any rules, you could get a few different answers. But C knows that multiplication has a higher precedence, a higher rank. So step 1, it does 3 times 2 first. The expression becomes 9 plus 6 minus 1. Now addition and subtraction have the same rank, so it just works from left to right. Step 2, 9 plus 6 becomes 15, and the final result is 14. These rules ensure you get the right answer every single time. And that's the whole trip right there. From grabbing the right toolkits at the start, to listening for input with functions like scanf, to processing that data using operators, and finally talking back to the user with printf. It all comes down to this simple, powerful cycle. Input, process, output. That is the fundamental heartbeat of pretty much every computer program ever written. So now you've seen behind the scenes. You know the core logic that turns your keystrokes into actual results. It's not magic, it's just a predictable logical journey. And now that you get that fundamental cycle, the only real question left is the one on your screen. What problem are you going to solve first?